Today we're going to talk about measuring angles and classifying different types of angles. So first let's talk about what an angle is. So an angle consists of two different rays with the same endpoint. You can see here in the diagram that we have two rays, ray AC and AB, but they have the same endpoint A. So we call the rays the sides of the angle, and we call the endpoint the vertex of the angle. So in this case, AC is one side of the angle, AB another side of the angle, and we would say that the vertex is at A. Now angles, when you're trying to name them, we generally name them using the vertex. Now it's not always that we use the vertex. Sometimes if the vertex is shared by more than one angle, we have to use points on the rays in order to make sure we identify which angle we're talking about. So here's an example. So here you can see if we were just to say angle E, it's not clear which angle we're referring to. If we're trying to refer to the one that's marked there, then we have to say angle DEF. Now notice the way that I've used the letters. So the middle letter is always going to be the vertex when we're talking about that angle. So if the vertex is at E, then when you name it using points on the ray as well, then you want to make sure the middle letter is the vertex, is E. So in this case, we call it angle DEF. So don't call it angle DFE or EDF. Always the middle letter should be the vertex of the angle. Now there is a tool that's called a protractor that's used to measure angles. And in this class, we measure angles using degrees. Now in terms of classifying different types of angles, there are 4 different types of angles. So here are the 4 different types of angles. The one that's here, the second one, is what we call a right angle. It's an angle that has a measure of 90 degrees. We use this in red there, a little corner symbol here, to mark that it is a right angle, that it measures 90 degrees. To the left of that, the one that's smaller than 90 degrees is an acute angle. So the measure of angle A here is between 0 and 90 degrees. Next we have an obtuse angle. This is an angle that measures between 90 and 180. And then the last one is what we call a straight angle. This is when the measure of the angle is equal to 180 degrees exactly. Now, how do you use a protractor to find the measure of an angle? Well, most protractors have 2 sets of numbers around the edge. When you measure an angle and need to know which of those 2 numbers you're using, you want to ask yourself whether the angle is an acute angle, a right angle, or an obtuse angle. So for example, if you are trying to find the measure of angle RST here, it looks obtuse. So between 110 and 70, this is going to be 110 degrees. Now the reason why they have both numbers is because you can measure from either side of the protractor. So notice the 70 really refers to that angle measure on the other side that, well, it's not labels there, but it would be TS, let's say TSU, angle TSU. So that way you can measure from either side and there's no problem. Now the protractor postulate says that the measure of an angle is the absolute value of the difference between the real numbers that the ray corresponds to on the protractor. So consider ray OB and a point A on one side of ray OB. The rays of the form ray OA can be matched 1 to 1 with the real numbers from 0 to 180. Alright, the measure of angle AOB is equal to the absolute value of the difference between the real numbers for OA and OB. So, for example, you can either see this as 140 minus 0, or you can see this as 180 minus 40. Either way, you can see that the measure of that angle is going to be 140 degrees. This is very similar to the ruler postulate, except that instead of you can think of a number line, you can think of it as a curved number line, and you're really just finding the difference. So find the difference between those two and take the absolute value, and that will give you the measure of the angle. Let's look at example 1. Find the measure of each angle, then classify each as acute, right, or obtuse. So the measure of angle AOD. Now for angle AOD, well, we see that A is there at 0, or 180. Let's start with 0. Then you see D, that's right halfway between 170 and 160. So that looks like that's at 165. So 165 minus 0 is 165. Now if instead you used the top number, then at A you see we have 180, and at D we're at 15. So if you did 15 minus 180 and take the absolute value, that will also give you 165 degrees. And then to classify that, that is absolutely obtuse. It is between 90 and 180 degrees. Let's look at the next example, angle COD. All right, so for this one, again, it's up to you if you want to use the top numbers or the bottom numbers. Either way will work. Let's try using the bottom numbers. So we see that ray OC goes through at 75, and ray OD goes through 165. So to find the measure of that angle, we do 165 minus 75, and then take the absolute value of that, and that gives us 90 degrees. That's going to be a right angle. Now, if instead of using the bottom numbers, you use the top numbers, we would have OC going through at 105, and OD going through at 15. And you can do 15 minus 105, take the absolute value, and that will also give you 90 degrees. Great, our next topic is the angle addition postulate. So similar to the segment addition postulate, the angle addition postulate says that if P is in the interior of angle RST, then the measure of angle RST is going to be equal to the measure of angle RSP plus the measure of angle PST. So essentially, in terms of the colors there, the angle that's marked in blue is equal to the measure of the angle in red plus the measure of the angle in green. All right, a couple more definitions we'll go over. So we say that two angles are congruent angles if they have the same measure. We talked a little bit about this before, but now that we've talked more fully about angles, we'll go over this again. So we use arc marks to show that angles are congruent to each other. So for example, here, these two angles are congruent to each other. So in red there, we've drawn in arc marks. So we would say in the diagram, the measure of angle ABC equals the measure of angle DEF. So you can write that angle ABC is congruent to angle DEF. Okay, and then we have an angle bisector, and that is a ray that divides an angle into two angles that are congruent. So just like before, last time we talked about a segment bisector, and a segment bisector could be a point, it could be a line, it could be a plane, but as long as it bisected or cut the segment in half, we would call that a segment bisector. So similarly, an angle bisector is a ray that divides an angle into two angles that are congruent. So it divides an angle in half. So here, for example, we have this ray JK, and we can see here that LJK and angle MJK are congruent to each other. So we would say that ray JK bisects angle LJM. And so those two angles are congruent to each other. All right, let's take a look at example 2. Ray BD bisects angle ABC. The measure of angle ABD is equal to 6x plus 3, and the measure of angle DBC is equal to 8x minus 7. Find the measure of angle ABD. Okay, so we're told that BD bisects angle ABC, so we know that the measure of angle ABD is equal to the measure of angle DBC. So let's start with that. Now we know the measure of angle ABD is 6x plus 3, and the measure of angle DBC is equal to 8x minus 7. So we set those equal to each other, substitute. And now we can go ahead and solve. So we'll add 7 to both sides, and we have 6x plus 10 equals 8x. Subtract 6x from both sides. We end up with 10 equals 2x. Divide both sides by 2, and we get x equals 5. Now, just because we found x doesn't mean we're done solving the problem. It asks us to find the measure of angle ABD. So now that we found x equals 5, we can substitute that into the expression for angle ABD, which was 6x plus 3. So this is 6 times 5 plus 3, so that's equal to 33 degrees.